Everybody, this is lab number 2, understanding TCP and UDP, and this is the supplemental video, and in this video we'll be walking through the lab exercise for IT Guru lab number 2. So to start out, maybe we should do a quick recap of the main segment of the lab, and a little bit more in-depth analysis is found within the lab document itself. But real quickly, we want to go through TCP and UDP. So the TCP and UDP protocols are transport layer protocols. And if you take a look at the OSI reference model, which is kind of used to describe how information flows in and out of the network stack, you'll see the transport layer here. And the transport layer's main purpose is to provide end-to-end communication between applications. If you look down here at the lower layers of the OSI model, you have your physical layer, which concerns itself mostly with just transporting the bits. It's the physical hardware, like your networking card in your PC, or a physical router itself, or the wires in the wall, things like that, completely physical devices. Then you move on to the data link layer, which more or less concerns itself with packets going through the local network. And then you have your network layer, which handles routing between local networks. And then you have the transport layer, and the transport layer is kind of the bridge between the routing and the bit handling, the bridge between all of those functions and the application type functions. So TCP and UDP are essentially the two most common protocols within the transport layer. TCP stands for Transmission Control Protocol, and if you've ever heard the phrase TCP/IP, it's probably somewhat familiar to you if you're already into networking. And it's one that is used mostly on the internet. So anytime you use your web browser to access a web page, or you use your email client to download new emails, you're using the TCP protocol that sits on top of the IP protocol that resides in the network layer. So TCP is a connection-oriented protocol, which means that before it transmits data from one host to another, it establishes a connection between the two hosts. And it does so using a process called a three-way handshake, which you can Google if you want to. I won't go into it in this video, but suffice to say that TCP requires you to establish a connection before you start transmitting data. It also requires you to tear down that connection. Both hosts have to agree to stop transmitting data before the connection's closed. And because it opens a connection, it also does things like establish buffer windows. It has sequence numbers so the packets are delivered in order, and it's a reliable protocol. You can get your data from point A to point B reliably. Now the UDP protocol is the user datagram protocol, and it's very lightweight. It's connectionless. It doesn't establish a connection between a point A and point B. It just decides if it wants to send data to point B to just go ahead and send it. No connection needed. It's up to point B to receive the data and piece it together. Because that's basically all it does is just send out packets as fast as possible, it's considered an unreliable protocol. You can't be guaranteed that everything you send from point A is going to make it to point B. There's a little bit of error checking that can be done because the UDP packets have a checksum value in there, but other than that, that's about all it's got. The whole point of UDP is sending out packets as fast as possible. So you might think that if we have a connection-oriented protocol that's reliable, why would we ever use UDP? Well, UDP does have its purposes because it's fast and it's lightweight and it has low overhead, and we can assemble a lab in IT Guru to sort of demonstrate that. So the first thing that we want to do is take the zip file that you either received from your teacher or you downloaded from the website. Go ahead and extract all the contents to wherever you feel like working. I always extract mine to the desktop because I think it's easier. So within that zip file, you have the lab document that you're probably reading, and then you have the Lab 2 files folder. And inside that folder are the files that we need to plug into IT grew so that we're able to do this lab. It's a pre-configured lab. I've set up some of the parameters and the things initially so that you have to do a little bit less work. So go ahead and open up IT grew. Let me drag it back down into the frame here. You can go to File, Model Files, then Add Model Directory. A little browser window is going to come open, and you're going to want to scroll down or browse to find that Lab2 files folder. In my case, it's right here on my desktop. And click OK. Now you'll be prompted with a little window that has multiple selections. Go ahead and click Source Directory. What that will do is any changes that you make to the scenario will be saved to the files in this folder. So if you're doing this in a lab, you can drag, after you're done with the project and you save, you can take these files with you on a flash drive or something and use them elsewhere. So now that we've associated this folder here with ITGrew, go ahead and click File, Open, and in your list of projects you'll see CSUMB_lab2. That is the project that you want. That's the one we just added. Go ahead and click OK, and the project will open. We have a map of the US here, and we're going to be basically modeling a long distance connection from one side of the country to another. And you see three little icons here: task configuration, an app configuration, and a profile. The profile, if you remember from Lab 1, is the profile allows us to create profiles that we can apply to devices in the network. The app configuration, or the application definition, was the way that we configured what tasks we wanted to happen. We configured the applications here, and then we created profiles that used those applications, and then we put the profile on the device. But we're doing things a little bit different here. We have applications, we have profiles, but we've created something called a task. The task allows us to do a very specific function within the scenario. So maybe we don't want to just have HTTP traffic. Maybe we want to control how many packets are sent when, how many connections are used, things like that. And so we've created a custom task here, and this task will have our client PC send one packet every second, and it will have it use a new connection every time it tries to send a packet, and it will have our server send back a single response packet. And so let's set up some devices so we can kind of see what we're talking about here. Go ahead and open up the palette and scroll down and see if you see a PPP server. Go ahead and click that and add it over here on the right side of our map. Now you can see here that there is a PPP workstation advance. If you don't see this device here in your palette, go up and click Configure Palette, Node Models, and scroll down the list. You'll see there's lots and lots of devices that aren't included. Scroll down until you see PPP_workstation ADV, and you'll click over here and it'll say included. Then you can click OK, and it'll add it to your palette. Now you can see right here Workstation Advanced is not listed because I've already added it to my palette. So I'm going to cancel out of there, cancel out of here. So now I'm going to add a PPP Workstation Advanced to the left side of my map. Now to simulate sort of generic IP traffic in between my workstation and my server, I'm going to add an IP32 cloud. Put it right there in the middle of the map. The next thing I want to do is scroll down to the PPP links, and I'm going to choose the PPP DS1 link. A DS1 is sometimes known as a T1. You may have heard of a T1 line, and I believe it's a 1.5 megabit connection You probably wouldn't have a T1 at your house, but a lot of businesses might buy a T1 line from a telecom provider. So we're going to have a DS1 or a T1 connection from our workstation to our server. So it's kind of a simulated business setup here. Let's go ahead and drag a connection to the IP cloud, then drag another connection to the server. So now we have a server and a workstation across the country that are connected with a point-to-point link, a T1 DS1 link. Our task configuration, as you recall, is going to have this workstation communicated in a very specific way to the server. Every second, the workstation is going to send a single packet to the server. The task is configured to have the server respond immediately as soon as it receives the packet. Now in the case of UDP, there's not going to be any connections created, so that won't make a big difference. But in the case of TCP, it's going to have a separate connection for each packet that it sends, much like you would in a regular environment. Every time you go to browse a web page from a different server, the TCP is going to be establishing a new connection, so we're going to simulate that here. In the next step of the videos, we're going to configure these devices so that they can have the applications tied to them properly, and then we're going to gather some statistics and kind of take a look at the difference between running TCP versus UDP.